So the other problem is, how are we going to print all the menus? When we have this, not this, we have this main menu. Underneath, I have a menu. I have some menu items. I have a C menu. Maybe I have a B menu. I have a D menu, which has some items. And there are some more items in here. And I want to be able to print this by an iterator. So that is my next problem. I mean, okay, we solved it. We can use either an interface, we can use an abstract class, but what we have is a, the structure that you know. This is the composite pattern. We solved it. Composite pattern is finished now. We learned about it. That was the composite pattern. Finished. We know how to do it. The relation that relates itself to itself. So that's good. We are relating itself to itself, and so we can handle it. So we have a component which is relating to its supertype, and its supertype can have multiple different types, but we can keep all of them. Okay. But now the second problem is an iteration problem, because in this case, when I say iterate and I'm starting from here, it has to do this. It has to come here first. And it will say, okay, are there anything inside you? There are. And this will say yes. And you will go like that. Do we have a next? Yes, do we have a next? Okay, so do we have a next? Yes. Yes. And when I come here, it will, when I ask, do you have a next? If I don't do it properly, it will say, no, I don't have a next. But if I do it correctly, it has to give me, yes, I have a next, and this is the one. And then, yes, I have a next, and that next is here, because this is a component, and I want to print only these people. And if I don't do it correctly, then it will say, do you have a next? No. I don't have a next. But if I do it correctly, then it will say, yes, there is, then it is here. So we need to find a kind of an iterator who can do this. And let's work on it. I mean, how can I do this? First of all, I can do it. Actually, it's not that difficult. I need some extra things to keep track. I need to keep track, because when I come here, I will say something like, okay, I want to print this. And I'm coming here. Give me the first item. I point to this one. And then what is the next item? I asked. The next item is this, actually. But this is a menu component. And I know that it is a menu component, and I say this is the next item. But since this is a menu component, what I need to have is I have to keep this in memory. I have to store this into my memory. But then, move on to this. That way I can solve it. So when it is finished, I say this is finished. and then I look at my memory. If it is also finished, then I say that I'm done, finished. But if there is something in my memory, which there is, I will break it up and I will keep doing it. Does it make sense? Is it okay? So in here, the rule should be, if you are a menu component, so that means that you have menu items under you. If you are a menu component, keep the next item in that level, the level that you are in. If this is this level, the next item, for example, if it is here, this is the menu item, this is the menu component. When I come here, I will say, okay, this is a menu component, then in that case, what is the next item? The next item is here, so keep this in the memory, put it in the memory. But then, move on to this, what is inside this memory component. And once it is finished, I will go back to the memory, my memory, and then we'll work that out. All right? So this is the way to do it. And I mean, are we okay with that? That's a good implementation. Then we will implement it. What do you think that how we can do it? You know, just by speaking, without doing anything. How can you do this? Well, I need some ifs and else's. Like if this is even not an if and else, not too many. But if it's a menu component, so I have a different way of doing things. When the next item is a menu component, I need to do something else. Just store something, and then when I'm iterating, I have to take care of the memory. So what is this memory, by the way? What would you be doing when it's a memory? What type of memory that we're talking about? It is not like, I have to program it too. I have to really program that too. This is not like the ordinary memory, write it in the memory. That has to be something that I put the object in it. So when I say that I'm going to keep this in the memory, I'm not going to I'm going to be keeping the entire thing into the memory. Actually, that's going to be at the pointer, not the exact copy of it. But so the whole thing will be in the memory. So what is that memory? What is the best way? Is it a list? So, but the beauty of it is that when it is read, it has to be erased from the memory because it is read. It has been read. So when I read it, we will delete it from the memory. So if it's a list, then when I remove it from the list, it has to be removed from the list. There was something, that
we may use Q, first and first out Q.
Yes, but there's a better thing. Commands like push.
Stack.
Yes, it can be a stack.